This is sections 13.6 and 13.7 on graphing and writing linear equations. A linear equation, as you know from algebra class, is an equation whose graph is a line. That's why we call it linear. And linear equations can be written in three different forms, but all of the different forms of the equations always lead to the same graph. We've got standard form. Standard form is ax plus by equals c, where x and y are your variables, so they'll be in your equation, and a, b, and c are any non-zero numbers. Slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept, the y-coordinate of the y-intercept, the point where the line crosses the y-axis. And point slope form is y minus y1 equals m times x minus x1, where again m is the slope and x1, y1 is any point on the line. So those will not be in your final equation. The regular x and y will, but the x1 and y1 will be replaced with numbers that represent any point on that line that you know is on the line. So for the rest of the video, we're just going to do a whole bunch of examples of graphing and writing equations. So let's start with our first one. Graph the line 2x minus 3y equals 12. That's an equation in what form? Standard form, right. So the way we're going to graph an equation when it's in standard form is to find we need to find 2 points in order to graph a line. The two easiest points to find are the ones that occur on the axis, the x-intercept and the y-intercept, because those have zeros, and zeros are easy to plug into the equation. So if we're going to find the x-intercept, we're going to set y equal to 0. The x-intercept is where it crosses the x-axis. If it's on the x-axis here, the horizontal axis, then the y value is 0. So for the x-intercept, we set y equal to 0, which means we've got 2x minus 3 times 0 equals 12, but 3 times 0 is just 0. So 2x equals 12, which means x equals 6. So the x-intercept is the point 6, 0, where the x-coordinate is 6, the y-coordinate is 0. Now let's find the y-intercept. For the y-intercept, x needs to be 0, so we're going to set x equal to 0. That means we have 2 times 0 minus 3y equals 12, or is negative 3y equals 12, because 2 times 0 is 0. If we divide both sides by negative 3, then y is negative 4. And the y-intercept is the point 0, negative 4. So now I've got 2 points, and I can plot these 2 points in the coordinate plane. 6, 0 is here on the x-axis. 0, negative 4 is down here on the y-axis. And I'm going to draw the line that connects them. And my line needs to have arrows on the ends. So notice how I've extended my line to cover the entire portion of the coordinate plane I've drawn. And I've graphed 2 points, and I'm going to label those 2 points as ordered pairs, 0, negative 4, and 6, 0. And I have arrows on the ends of my line. You need to do that on every graph you graph in this class. The line needs to extend over your whole graph. You need to put arrows on the ends of your line to indicate that it goes on infinitely, forever. And you need to label at least 2 points on the line. You need to label and number your axes as well. Let's take that same equation, 2x minus 3y equals 12, and let's write it in slope-intercept form to see how we can go from standard form to slope-intercept form. And then we're going to graph it from slope-intercept form, and notice that we get the same graph as we got before. So 2x minus 3y equals 12. If we want to put that in slope-intercept form, remember, slope-intercept form looks like this. You've got y equals mx plus b. So I need to take my equation and get y by itself. I need to solve for y. So if I'm going to solve this for y, I need to get the x to the other side. So we're going to subtract 2x from both sides. So negative 3y equals negative 2x plus 12. I'm going to write the x term first because that's just the standard form of it, or the way we normally write it. And then I'm going to divide both sides by negative 3. But I need to divide everything on the right side by negative 3. So y equals, now negative 2 divided by negative 3 is positive 2 over 3 with an x. And then positive 12 divided by negative 3 is negative 4, so minus 4. Y equals 2/3 x minus 4. And that is slope-intercept form. The way I graph it from there is to pick out the slope, m, which is the number in front of x, so 2/3, and the y-intercept, b, which is the number on the end with its sign attached, so negative 4, which means the y-intercept is the point 0, negative 4. So here's how I'm going to graph it. I'm going to start with the y-intercept and put a point there, 0, negative 4. Then I'm going to use the slope to find another point. Now the slope, remember, is the change in y over the change in x. Change in y is a vertical movement, so we're going to go up 2, and then we're going to go to the right 3, which puts me here. What is that new point? Looks like 3, negative 2. And then I'm going to graph or connect the 2 points with a line with arrows on the ends. And the line extends over my whole graph. So that's the way we graph from slope-intercept form. As we plot the y-intercept first, we use the slope as a change in y over a change in x to find another point, and then we connect them. So let's do that again with this. Graph the line y equals negative 3/4 x plus 6. So it's already in what form? Slope-intercept form. Oh, you're so good. So let's graph it using the slope of negative 3/4 and the y-intercept b of 6, which gives us the point 0, 6. We start with the y-intercept. This time our slope is negative. So the negative is always going to tell us to go down instead of going up. So we're going to go down 3, and then we're going to go to the right 4. We're always going to go, if it's negative, go down, but still move to the right for the bottom number. So then we're going to connect those 2 points with a line that extends over my whole graph with the arrows on the ends. And what did I forget to do? I forgot to label the points. So this is the point 4, 3, and this is the point 0, 6. Now my graph is complete. Now how about writing equations of lines, if we know things about them? So number 4 here, I have the slope is negative 5/3 and the y-intercept is 4. And I want to write the equation of the line. Well, if I'm given the slope and the y-intercept, what's the best or the easiest form of the equation of the line to write? A slope-intercept form, because I've got the slope and the y-intercept. So the slope-intercept form is y equals mx plus b. We plug in the slope of negative 5/3 for m. We've got the x, which will stay there, and the b is our y-intercept of 4. And that's it. We can easily plug it into the slope-intercept form. What if I have the x-intercept and the y-intercept? Well, that's really 2 points. The x-intercept is negative 6, 0. The y-intercept is 0, 3. So I can use slope-intercept form where I know b is 3, but I still need to find m. So I need to find the slope. Slope, remember, is going to be the change in y over the change in x. y2 minus y1 over x2 minus x1. So that's going to be 3 minus 0 over 0 minus negative 6, which is positive 3, over positive 6, which is positive 1/2. So I plug that into my equation for m, and I get y equals 1/2 of x plus 3. And that's my answer in slope-intercept form. Now what if instead of the intercepts I'm just given any 2 points? Well, I can find the slope the way I just did. y2 minus y1 over x2 minus x1. So that's 8 minus 0 over 1 minus negative 3. 8 minus 0 is 8. 1 minus negative 3 is 1 plus 3, which is 4. And 8 over 4 is 2, so the slope is 2. Instead of going to slope-intercept form, which we could do, let's try a different form. Let's try point-slope form. Point-slope form is y minus y1 equals m times x minus x1. We've got the slope of 2, so that's going to be m. x1 and y1 is any point that's on the line. We're given 2 different points. We've got negative 3, 0, and we've got 1, 8. We can use either one. It doesn't matter. Either one in point-slope form will look different, but in slope-intercept form, if we rewrote it in slope-intercept form, they would end up the same. So it doesn't matter which one we use. Let's use 1, 8. So y1 is the y-coordinate, which is 8. M is the slope. And x1 is the x-coordinate, which is 1. And that's it. That is in point-slope form. How about the line through 1, 2 and parallel to the line y equals 3x minus 7? So we have to remember something about parallel lines from last section. What do you know about parallel lines? They have the same slope. So, what is the slope of the line that we're given here? Y equals 3x minus 7. Slope is the 3, the number in front of the x, because it is already in slope-intercept form. So we're going to take that slope and this point of 1, 2, and that is the equation we're going to want. Now we can do it in point-slope form. Let me show you how to go directly to slope-intercept form. So y equals mx plus b, where m is 2, but we need to find b. Sorry, m is 3. What was I doing? Come on. Okay, m is 3. So we need to find b. The way we can find b is to use the point that we're given, 1, 2. 1 is a value for x and 2 is a value for y. So let's plug them in. And then let's solve for b. So 2 equals 3 times 1 is 3 plus b. If we subtract 3 from both sides, then b equals negative 1. So then our final answer is y equals 3x, then plug in negative 1 for b, so minus 1. And that would be our answer in slope-intercept form. So that's how we do it if we want a parallel. What if we want perpendicular? What do we remember about perpendicular lines? Their slopes are negative reciprocals. So if the slope here is 3, the slope of the line we want to find has to be the reciprocal of 3, which is 1/3, and the opposite sign. 3 was positive, so we want negative 1/3. So let's try point-slope form. Y minus y1 equals m times x minus x1. We've got a point, 1, 2, so the 2 is the y1. We've got the slope of negative 1/3, and the x1 is the 1 that comes from this point we were given. So we can stop there if we want our answer in point-slope form. And that is an equation of that line that's perpendicular to the line we were given. If we were to graph both of them, we'd notice that they would make a perfect right angle. So here are your immediate practice problems. On numbers 1 and 2, you need to graph the line and make sure you label 2 points, extend the line to the edges of your graph, and put arrows on the ends. And for numbers 3 and 4, you need to find the equation of the line described. You can put your answer either in point-slope form or in slope-intercept form, whichever one you would like. Make sure you show your work, and that is the end of sections 13.6 and 13.7.